Team, welcome to QA plus manual testing day one. The previous session that we had was an orientation session. Typically, the orientation session we covered it on what we're going to learn. Probably I'll just quickly recap for the benefit of the people who are just joining today. So we thought throughout this complete QA live training program, we are going to cover starting from today. We'll try to understand some of the fundamental concepts like the importance of software testing, what is software testing is all about. The difference between QA and QC is one of the common thing that you keep on hearing about it, quality assurance, quality control. With the quick points, we will be able to differentiate them today, what exactly QA and QC is all about. The entire learning will be through a project approach, a practical approach, or an application-based approach. So we will start writing the test scenarios and test cases. So that's the next immediate thing that we're going to look at. How can we write test scenarios? How can we write test cases? What are the things that we need to consider while writing the test cases? What is test step is all about, expected result, actual result, etc. We are going to look at through a practical way of writing it, because this is one of the primary or first deliverable that you are going to give it to your test lead or test manager when you join as a QA member in the team. And then we will be looking at how do you go about executing those test cases once the developers completed the build, they have completed the coding. How do you go about execution of these test cases? Basically nothing but you're performing the testing, and while performing the testing, things may work as expected, may not work as expected. So anything that is deviating from the expectation of the customer, or anything that is deviating from the requirements that we have got it from the business, we call it as a defect. So then you will be able to decide whether it is a defect or not, and then you will prioritize it. You will be able to assign a severity to it, like whether it is a critical defect or a medium defect or a low severity defect. So you need to understand the definitions of it. What are those severities, priorities, and which one you can call it as a reproducible one, which one is non-reproducible one. All those things we'll be learning through. And typically in the live project cycle, when you find the defects, not everything will be accepted by your counterparts of development team. Probably sometimes you may go wrong, like you may think something is not working correctly, but actually you're doing a mistake. Application is working fine. So in all those three scenarios, defect triage meeting will happen, in which people will, people like test lead, dev lead, project manager, or product owner in today's terminology of agile will sit together and decide whether it is really a defect or not. If it is a defect, then what is the severity, what is the priority, etc. We are going to assign them to the corresponding defects. First deciding whether it is a defect or not. If it is a defect, then what is the criticality or complexity of it. So that's the next immediate thing. And then we'll also try to understand some of the challenges that you will be facing during the testing projects. It could be time crunch, that your test lead might come back and ask you, hey, this is the application, can you go and validate this, and for which I'm giving you 2 working days of time. Probably if you go with a proper testing, that might take 4 working days or 3 working days. But you have to complete your analysis and testing, and then you should give a sign off whether you are able to sign it off or not in 2 working days of time. So here we are talking about a challenge of time crunch. And other challenges could be that most of the times you may not have clear requirements. Then how do you go about writing the test cases for that? How do you go about testing for that? So we'll definitely discuss some of the challenges and how you can overcome them. Then we'll talk about software development life cycles. The predominantly used ones are the waterfall, and in today's world most of the people are using agile. So we'll see what is the difference between these two, and how the testing that fits in agile. So this is the next point, comparison of traditional testing to agile testing, and how do you plan your agile testing, what are the roles of testers, and understanding this 4 agile testing quadrants. Then we'll talk about different testing methodologies like black box, white box, gray box testing, as touched upon this, some of them in the orientation. So you should also go through the orientation video, people who could not make it on that day and who are just joining today. So we kind of touched upon black box, white box testing based on the questions that I was getting it. Like people were asking, do I need to have any programming knowledge? If it is, which programming knowledge and all. So I kind of said, if you're going to work in black box testing, and we are talking about manual testing here. So manual testing with the black box, you absolutely don't need any programming knowledge. But if you go to white box or gray box, then you would need some amount of programming skills. But looking at the number of percentage of jobs in the market, black box takes a major role because of its, the people who come from white box and gray box knowledge obviously, demands more package, salary, etc. They are equivalent to developers. In fact, they should have good, much better knowledge than the developers. So there are very few companies, product-based companies like Amazon, Google, Microsoft, Oracle, etc. They will try to apply this white box and gray box for their product testing. But if you look into the major services world, is where the black box testing plays major role. 70 to 80% of the testing happens through black box. So that's where absolutely anybody from any background, not only from computers background, can go about doing the black box testing, as long as you understand how to write test cases, how to, testing, how to go about testing them. And there are different testing techniques, as we will be walking through, or understanding them in detail, like unit testing, integration testing, system testing. You might have heard these through by now through your friends, or if you're doing some kind of research on what is this testing is all about. So functional, load, performance, usability, GUI testing, globalization, localization testing, etc. So there are many other testing types which I'll be discussing with an examples. It's not that in every project you do all these things. Definitely the first one, unit testing, is something that we don't do it. It's always done by development team. So we can actually, but only thing we'll try to understand what happens there, and it is always done by development team. But the rest of the things are the one that we are going to do it, and we'll see an example for each of them. And then finally, so when you do all this, as I was saying, it's not that in every project we do all this, depending on the need. In one of the project, you may require to do only functional testing. In another project, you may require to do functional testing plus security testing. So depending on the need, you're going to perform. Okay, so Durga has a question. What programming skills are required for white and gray bag? So that depends on which project you are working with, which product you are working. Suppose, let's say you joined as a test engineer for a product, and that product is developed in Java. So you would go learn, you would go review the Java code. So you need Java knowledge in that. But again, I'm telling you, it's hardly 20% of the market is on white box and gray box. So depending on the product in which you're going to work. So the last point that we're going to talk about is test sign-off criteria. When we should actually stop testing, and how can we sign off, what information that we should provide when we are actually signing off. So all that we are going to look at, and post that it will go for customers testing. It's called user acceptance testing, and they will do the testing also, but it is not going to be such a detailed testing as what we do. It will be very high level testing that users will perform, and if it is they are satisfying with the implementation that we have done, they will give a signal for going into production. Otherwise they may say, no, we are not satisfied with what you have developed and tested, and probably they reject the project. So that is how things will go. Okay, so apart from this, I also wanted to talk about some of the other topics. Some of them may not be covered immediately in this one, will be covered through the upcoming sessions on Jira and automation that we will be dealing at IT-Learn, but I will be kind of introducing them what they are, and so that you have a fair idea about them. Okay, Meenal has a question. Once we finish the complete manual testing, we can start working in project. or do we need to know some tools? So see, the overall testing in the market happens through two areas. Probably let me explain it in a document. So there could be only manual testing in a project, and there could be manual plus automation testing in a project, right? So, and if you are going to, sorry, if you're going to join in a company where the team is using only the manual testing, and you will be learning all the fundamentals required for it and how to write test cases and everything, I can pretty much assure, yes, you will be in a position to take up this project and you will be working as a proper professional software test engineer in manual. But to answer your question, if the company that they are hiring you, they are using both manual plus automation, probably they may also check knowledge on automation side also, whether it is Selenium or UFT or any other tool. Because it is being very common in hiring process nowadays. They're not just hiring with only manual testing background, because tomorrow if they have to do an automation, they don't want to go about hiring it again. So they want to hire somebody at this moment who have both the knowledge, manual plus automation knowledge. But again, most of the companies, even though they hire for automation, how much percentage of automation that they are really doing it in the organization, it differs from project to project, team to team. But to answer your question, Meenal, it is always better to prepare both and be ready yourself, so that when you go for an interview, if there are any questions on the automation side also, you won't actually miss them. But if somebody clearly told you we are hiring only for manual test engineer, then what we are going to learn in these 12 sessions is good enough to go try out for a manual testing job. Okay, Deepa has a question. Even if I don't mention about any programming knowledge in my resume, do they still consider? Yeah, so programming knowledge is not something that is mandatory when you go as a test engineer. But again, coming back to the same question, the moment you say I have some knowledge on automation testing, automation tool works with some programming. So which programming knowledge that you have to put it in your resume. Suppose if I say Selenium, probably it could be Java or C Sharp or Python or anything. If it is UFT, then you would say I know VB script, etc. Uh, Abu, we ALM course will be there, but that's not part of the QA plus like QA manual testing. So QA manual testing covers all the QA part of it, and we will be also covering Jira. Uh, it will be discussed in detail through a separate sessions, but you are part of it. And then Bugzilla will be shared you through videos. But ALM is altogether separate. Okay, so I think the same question coming it in different ways. Let me answer this again so that, hope you are all clear. No, quality center or ALM is the same thing. It's altogether a separate. It is a test management tool, but we are not covering as part of this course. Okay. So again, same question. People are asking it in different way. Let me ask this one. The question that I just got it is, I'm new to the testing, so do we need to learn Java for automation? This course is all about manual testing, and let me tell you, you don't need any programming knowledge. But to get your dream job in the testing industry, there are two types of jobs that you would see. One only with manual testing, one with manual plus automation testing. Which job that you are applying, that you have to be very clear. If you are going to apply for only manual testing, then they won't expect you any programming knowledge. But if you're applying for a job on manual plus automation testing, yes, they would expect you some programming knowledge based on which tool that they are hiring for. If they are hiring for UFT, you should know VB script. If they are hiring for Selenium, you should know Java or C Sharp, depending on what you trained and what you practiced. Yeah, that's pretty much clear. I'm just moving ahead. I will try to answer any of these questions towards the end of the session. Just keep posting it and see which are relevant. I'll try to answer. Okay, so these are the topics that we have finalized, kind of considering it what is latest in the industry, and I'll also touch upon some of the new things in the industry like test-driven development, behavioral-driven development also as we go ahead. But pretty much I created this Google Drive document in the last session, and these are the topics. Pretty much whatever I've showed you in the PPT, we kind of copy pasted into this Google Drive. So I will be sharing this drive post today's session with people whoever has completed the registrations and everything. And this is your of course the videos are your primary source. Anytime you should go back and refer to those videos when you wanted to re-understand the concepts better. But offline you can also get this document to understand what we have discussed in the sessions. Okay, the very first thing that we will wanted to understand is typically what is software. As most of you are saying, let's try to define this, what exactly this software testing is all about in a quick way, and then we'll start with the test case writing. That is the most practical way of learning the software testing. As we try to write test cases and try to understand more concepts, we'll discuss them. Okay, so typically software testing is nothing but you have seen different forms of software. You are in fact using the different forms of software, like you might have used desktop applications as part of certain need, or you're nowadays using most of the web applications. It could be any social networking application, or it could be a registration, online registrations applications, or it could be any of these go-to meeting through which you're trying to join an online meeting. So you have many applications. You also have applications that are going to run on mobile applications, your smartphones, tablets, etc. So there are different forms of software that is available in today's world, and all these softwares are placing a major role in our day-to-day life. And just imagine if there are any issues in that, if there are any problems in that software, as a user, what kind of situation that you will be in, or what kind of difficult times that you will go through. For example, just to talk about some of the examples, let's say you go to one of the mobile application for booking certain tickets for a movie, or or maybe for an event, and you're facing a lot of performance issues there. It's a very slow, and the application does not load all the information properly, or after very difficult times you got the application, you have made the payments, and you got a confirmation saying that your ticket is booked, but it does not send you any notification to your email, or there is no message from it confirmation. So you are kind of skeptical whether to, even after going to the event, whether my ticket is booked or not, unless you go collect your tickets. So there are certain kind of problems that you go through in the entire phase of booking a ticket, or it could be an online banking transaction that you try to do. If there is any issue as a customer, you'll have to go through a lot of pain, you'll have to go through a lot of rework. For example, let's say you're filling up an online registration form. You filled up most of the values, right, starting from your first name, last name, to your academic details, so much of information that you have provided, and suddenly you see that the application is not responding, or the application is taking a lot of time, or crashed, for example. So what kind of situation that you are in, like you are going to do a lot of rework, refilling it, etc., etc. So those are some of the typical problems that we encounter. The idea behind software testing is to eliminate all the issues. You can call them as any name now, all the issues, or you can call with a name called bugs, or you can call with a name called defects, or you can call them as errors before it goes to customers. So what is your primary job is that the purpose of software testing is eliminate all these issues, whatever I just spoke. They see, most of the applications that we are using in our day-to-day life are already tested. They are all well tested, and that's why you won't see major problems. But if you see any application during the development, as soon as it just completed the coding and just completed the development, if it is given for you for the testing, there will be n number of issues in that software. And the expectation from you is that eliminating, if not all, I think all is definitely something that nobody can guarantee. How can we guarantee that we have eliminated all the issues? Even if you have covered, I mean, so but we have to try to do as much as possible. That's where you're going to learn how to think through positive, negative scenarios, and how do you overcome all those issues in the software. If not all, let's say most, so you are going to eliminate most of the issues or bugs. Right now, you can use any of the word. We will be able to differentiate as we go. Issues or bugs or defects or errors before it goes to customer. Otherwise, it will be a major problem in terms of reputation to the product in which the the product the company in which the product got developed. Think of a situation like this. Suppose you are transferring some $1,000 from your account to your friend account, right? So you got a confirmation saying that transferred successfully, but your friend says it's not being you know credited to my account yet. So in what situation you will be in, right? Probably fine. You may log a complaint to the corresponding bank. They evaluate it, and they'll come back in a day or two saying that hey, sorry for the transaction failure. There was a problem, blah blah blah, and they will try to revert back money to your account. All those things. There is a process to get it back. But think about as a user when you're actually doing it on the fly, what kind of experience that you have, and all these are all still fine. But if you go into major critical projects like healthcare domain, just think about any nowadays complete hospitalization systems are automated, diagnosis systems are automated. Think of something from those lines. Suppose if a person, a patient goes through some diagnosis and there is a report comes out of it, and let's assume that's a there's a defect in that, and based on that, doctor is giving the medication. So the worst thing that could happen is the cost of life of a person, right? So that's the value that we are talking about here. What as a test engineer you are going to add value to the system, right from a simple video game software that our kids will play. Even that is very critical. I don't know how many of you have experienced this. If especially my daughters will do like that. If any of the video game is playing very slow because of my broadband, they understand all that, right? So, or it could be an application, the problem with the game itself. They simply try to throw the tablet on the ground, or it could be a mobile. So it's cost of that particular thing, right? So right from a very simple application to the critical application like in a healthcare related applications, or anything that's related to NASA related applications, or even most of the things are automated. So if there is any problem, that will create lot of issues in real time, and we wanted to eliminate all of them as they go and used by the customers. So typically you as a test engineers, you are pretty much working like a user. You will actually get into the shoes of a real customer who will use our software and see what are all, once we release the software to customer, what are all customer can do. For example, let's say a Facebook application, for example, a social networking application like a Facebook, right? So think through all the scenarios. Probably you may be using only 4 or 5 features, but there could be so many other users of the system will be using 100 features of that particular thing. So, but you as a test engineer, you will try to think through all of them and try to do all of them before you sign off, and ensure that all the features are working as the way we wanted, and then we deliver it to the customer. So this is the typical value that you will be adding to the software systems when you join as a software test engineer. And to be frank, most of the customers or clients nowadays are worried about, they are not really worried about who's developing my project and how it is and all. People are worried about who is the testing team, what kind of qualifications that they hold it, or if required, some of the clients are doing one round of interview with the testing, because if the testing is very good, the quality of the project will be good. If the quality of the project is good, that means his achievements in terms of what they want to do with the software system is good, right? So you definitely have a high value in the organization. Anything that you say, I'm done with the testing, it's working as expected, take it to the next level, people will believe you. That means you are actually done everything and then you are signing off. At the same time, after you sign off, if something goes wrong, probably the first question to be, first people to be questioned is again we as a test engineers, because we are the one quality gates, we are the one quality checks who are signing off. So people, there is a right for the people to ask the questions to us. And yes, we are also human beings, and there could be some situations where things can go wrong, mistakes can happen. But that's where I said this all or most. You may not be able to eliminate all of them, but at least you should be able to eliminate most of the issues that as a team, and you're not the only member. As a team, you're going to work, right? So will someone cross check before sign off? So that's where. So when you join as a test engineer, you will be slowly learning and things and doing, and that's where your test lead will be there. But as you grow, uh, you are the responsible for majority of it. Definitely your test lead and test manager will review all your work. They'll review your test cases, they will review how you're testing it, they will review the quality of the bugs that you're logging it. Yes, someone will be there, but my suggestion is that let's try to be as independent as possible. That's the whole thing we're going to learn over here. Okay, so let's, after understanding that, let's move ahead to another quick definition of it. Uh, so you as a test engineer, you're going to work in a department called quality department. But within the quality department, there will be two teams. One is called quality assurance, and the other one is something called quality control. So you might have heard about these two teams, and a lot of people use these terms very interchangeably, and that's where the confusion comes. So people say QA, people say QC, etc. To be frank, we as a test engineer, we are not QA at all. But again, if you see the way we started, we have said it's a QA plus manual testing and everything, because people have using that word very predominantly. So we are actually QC, we are quality control. So quality control is nothing but a test engineer. But again, since if I start using that word, probably some of you may or may not get it. So that's why I also started using it. But let's, at least after understanding this difference, I'm sure you will be able to differentiate what is QA and what is QC is all about. Okay. So typically what happens is that, let me see if I can just add one quick table, a 2 by 2 table. Okay. So let's take quality assurance here, or a QA team. And let me take this quality control, which is nothing but QC. Okay, so in any organization, what happens is that there will be a team called QA team who will be working for many projects, who will be working at the organizational level, not even a project level. And what they try to do is they define the process. What is the best process for the company, or projects that are getting executed in the company. Process, right from what development life cycle that we have to use, what testing life cycle that we have to use, and whether it is a waterfall model or whether it is an agile model, or in case of a testing, whether you should go for something called test driven development or a normal testing. So they come from a very rich experience. They have about I would say minimum 8 to 10 years of experience in the industry, looking at different processes, different projects. And they also may come with certain certifications like Six Sigma certifications, or it could be like black belt, green belt certifications, or it could be an ISO CM, basically the certifications that are related to a process, CMM certifications, etc. So they are the one who will define the process for the company or the projects within the company. And in other way, I can also say that they are responsible for prevention of the defects. So what they are actually going to do is they are majorly responsible for the prevention of the defects. Let's take this point little later. So let's talk about the first point. They are responsible for the prevention of the defects. What is the prevention of the defects? Before even a software defect introduced into the software, before a defect is introduced into software, how best we can prevent it, what are the best practices that we should do, like how do we gather the requirements of the project, how do we do the design of the project, how do we do the coding of the project, after coding how we should do code inspections, code reviews, how do we do unit testing, so that we can eliminate the bugs before even they occur. That is a prevention. So just the highlighted word to be here, prevention of them. But we as a test engineer, we are responsible for detection of the defects. So how much ever prevention that you have taken, still there could be some defects in the software. And if there are defects in the software, identifying those defects is your primarily responsibility. That is your primary responsibility. So QA team is something who will try to prevent them before they occur with their experience of process, learning, tools, etc., what best they can do. But even after that, there could be still some problems, and those problems is what we are going to identify, and that is our responsibility. And how they are going to prevent the defects? So they will define the process, what best works for the company or project. They define the process for the company or project. And what we should do, we have to follow the process. Follow the process, you know, uh, defined by the QA team in the organization. So what is, they might give you 2 3 options. If this is a project, this is the methodology you have to use, and if your project is shortly delivered, then probably you have to go to agile. So they'll define the process, and the process may or may not 100% suit for our need. Of course, our project manager will go talk to the QA team and then customize the process or tweak the process a little bit here and there, what is that suits for our project need, and we have to just follow that process according to that. And what is a guarantee that you're following? For example, you have signed up for test driven development, that you wanted to write all your test scenarios and test cases first, and you wanted to give it to development team will develop it according to your test cases, something like that, a process you have signed up. And what is a guarantee that you are following it or not? So they will conduct internal audits. So basically they will conduct internal audits on monthly or quarterly basis to check the adoption of the process. So whether the teams are adopting the process or not properly, so they will come back and check on a monthly or a quarterly basis whether every team is following it or not. And what is your role as a test engineer? So we have already said, right? So quality control is nothing but a testing team. So what is your role as a testing engineer is that you need to provide all the required documents or tools that you are using for the audit. Suppose as part of the process, they mandated that you have to use Jira as your test management tool for all writing your test cases, logging the bugs. They clearly told you should come out of the Excel. You should not write any of your test cases in Excel. You should not log defects in Excel. You should use Jira tool. And what is a guarantee that you are, to the extent that you are using? So when they come for the audit, you will have to show them, hey, here is my project and this is my Jira project management tool, and here is my project, these are my test cases, these are my defects, etc., etc. So that's when they will be able to confirm that you're actually following it. The other thing that we can talk about is that their primary principle is verification. So you might have heard about these two terminologies again, something called verification and something called validation. So again, these are slightly different. So our primary principle is validation. We don't Let me just define them. So QA team majorly works on a principle, something called verification. What is a verification? Suppose if I give you a document, if I give you a document or an Excel or um, probably some requirement document, if I give you, what exactly you do in that is you try to, yeah, okay, so just let me try to answer this question that Jitendra had. The way you have created the package QA manual testing, does it include everything that is needed to become a manual test engineer? How many hours of this course? Jitendra, that's where you should please watch the orientation session, but let me quickly confirm, yes, this we have designed it in such a way that it will cover both your complete your manual testing related information, not any of the automation. Automation is altogether different, but I think you're on the right understanding. It's yes, manual testing thing. And the sessions are going to be about 12 sessions, which I'm going to deal it. And there are already sessions Karthik has covered it in previous batches. Those access also will be given to you. Uh, Put together, you will have anywhere less than, definitely not less than 20 sessions. Does that answer your question, Jitendra? But again, I would strongly recommend go watch the orientation session that I have done last week. Cool. So their primary principle of QA team primary principle is verification. As somebody, putting it in the chart, Durga says cross confirmation. Somebody has written a document, you go through, you review it, and you say, hey, here is a problem. I think this requirement is not clear. This is not consistent. In section 1.1 is saying something, section 1.5 is saying something. I don't think they are in sync. So you can identify those kind of problems. You identify. See, even as a test engineer, not only you will identify the problems in software, let me also tell you that. You will also identify the problems right from requirements itself. Somebody gives you a requirements document, you will go through, you will understand if there is anything that is not clear to you, anything that is inconsistent, you will still raise as an issues, you will still raise it as a bugs within that particular requirements document. So don't think that we'll always do validation. So typically our primary principle is validation. So what exactly validation is? Somebody gives you a piece of working software, and that software you will run it and you will validate it, whether it is working as expectations of my customer or not. For example, a simple application, let's say anything that you can think of. Maybe a LinkedIn application through which I can connect through my professional networks. I will log into the application. I will validate each and every feature, whether it is working or not, to match the requirements of the customer. So that is called validation. But to be frank, actually testing team does, as I was saying, we do both. We do verification, we do validation also. Okay. When do we do verification and when do we do validation? So let me just give you this example. So in a typical project lifecycle, SDLC lifecycle, there are different phases. It starts with something called a requirements gathering phase. Then it goes to something called a designing phase, and it goes to something called coding or development phase. Then comes the testing phase. Testing phase, people also call it as stabilization phase. A stabilization phase where you're actually stabilizing the system by eliminating all the bugs. Then you will have implementation, implementation or deployment, and the last one is something called maintenance. After you deploy the software, there will be a maintenance or a warranty period. If there are any problems that my customer is facing, we'll fix it free of cost in that maintenance or warranty period. So this is how typically a project lifecycle will go through: a requirements gathering, design, then coding, and then testing, implementation, and then maintenance. But you as a test engineer, if anybody understands that you will come in the fourth phase and do some job, that is not correct. That was the very old scenario about 15 years back. when testing got introduced, people used to involve the testers only here. Involving the testers only here is not going to help, because you should understand the requirements of the project, you should understand the design of the project, you should work with the developers as much as possible, how they are writing the logic, what kind of logic that they are implementing. Then only you can add value to testing. So nowadays, in today's world, you will see the testers are there from every phase of the life cycle. It's not that you will be coming only in testing phase and going away. So now what exactly you do in requirements phase is, what you do is you review the requirements. Whatever the requirements that comes, you review those requirements. Now reviewing these requirements is nothing but a verification, right? And what you do in design also, you would also review the design. This is also called verification. Sometimes before we go for coding, we do something called prototype. It is recommended in most of the applications to develop prototype. And what you do in prototype, again, the same thing. You review the prototype. What you're actually doing is nothing but a verification again. After the coding is completed, what you do actually in testing is nothing but a validation. So you will execute the test scenarios or the test cases that you have written. So this is a validation. So in a way, you're doing the verification and you're doing the validation also. That's why I can easily say that testing team is nothing but we do both verification as well as validation. But somebody coming from a QA, quality assurance, they majorly do verification. Right. So any questions so far? Another thing that we can also add it over here is that verification we can define with some question like, are we building the product right? If you look at this question, this is more sounds like a verification. And if you want to understand more clear difference of validation, it is like, are we building the right product? Do you guys see any difference in this question, or is it same? If there is a difference, what is the difference? First of all, is there a difference? Are we building the product right? Are we building the right product? Right is placed in different place. So exactly correct, right? So, but what is that? But just by placing the right in different place, is it sounding too different or same? It's totally different, right? For example, if you see the first one, yeah, it's totally different. Are we building the product right? We are not bothering about which product we are building here. It could be any product. It could be an insurance product. It could be a domain, financial domain project. It could be a banking related product, any product. Are we developing it right? So if you see, the mode sounding is towards the right. That means whether we are doing it correctly or not, the process is correct or not. The sentence meaning is changing with the right in, yeah. So verification means we are questioning the developer. No, 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 no. It is not like that. Just by using the word building, it's not correct. So just by using the word building, we are not questioning the developer here. We are questioning the process that we are following. As an organization, it could include developer, project manager, tester, everybody. Whatever the process we are following, that is correct or not is what we are questioning here. It's not just about developer. So please, we have to, again, a lot of testers. Okay, I'll come to those questions as we go. But to answer your question, Uma, it's not just about development team. It is overall team that we are thinking whether we are doing it correctly or not. If you look at the validation, are we building the right product? We are focused more on the product is right or not. If whatever the product that I am working is, the product is right or not. If there are any problems, then I will be the one to be responsible. I should eliminate all the problems in the software. There should not be any UI errors, functional errors. There should not be any business logic errors. I'm going to eliminate everything. My focus will be totally on the product that I'm working. So it sounds more like a testing, right? So validation is, are we building the right product? Verification means, are we doing the process in the right way? Validation means, are we building the exact product? So as VAT says, perfectly the same thing. So here we are looking at a process. What we are following is correct or not is what we are sounding. And here if I'm a responsible test engineer for a product XYZ, my focus will be on the product XYZ to eliminate all the problems in that software, right? So as Vats is saying, their primary focus is on the process. Always QA team look at process, whether the process is correct or not. Should we need to enhance the process? Should we need to modify our process? So that's what, whereas our primary focus is on the product that I am working. If my product is, as I said, an insurance product with an MXYZ, so my focus will be on the product to eliminate all the problems. So this is a kind of a difference that we can give it for a QA and QC, but again, a lot of people use it interchangeably, and definitely nothing wrong in using that, but only thing, be clear. For example, let's say after completing this course, you find a job description in the market, you find one job posting in the market. They say we are looking for a QA engineer with 3+ years of experience in manual testing, automation testing with Selenium. I'm just giving an example, etc., etc. So by looking at the JD, you can understand that they're actually looking for testing people. They're not really looking for a process people, right? So we have to go through the JD, then you should understand, because these words are very interchangeably used. People still may say we are looking for a manual QA engineer. That means manual test engineer they are looking for. But if someone clearly gives a job description as we are looking for a QA engineer with about 8+ years of experience in the implementation of the process, people should well versed with ISO, CMM, Six Sigma, blah, blah, blah. So that is totally not related to you. It is something, a process related job, basically a QA, quality assurance job. You can also go there after 8-10 years of experience, but not immediately as a test engineer. So that's the kind of a difference that you have to go through to understand what QA QC is all about. So any questions on this team with respect to the terminology QA and QC that people we frequently use it? You have to be very clear on that. That's what I want to cover it in my first topic today. Clear, right? So you are going to, and one another thing that I can add you as a software test engineer, you will be testing it on different machines and hardware. So you will be doing a lot of compatibilities testing. You'll test it on different platforms, different browsers. As we said, you will be doing it on mobiles. You'll be doing it on tablets. So depending on the type of the application or the project that you're working on it. So you will be doing it with a lot of compatibility testing also. No, 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 no. Operating system. Yeah, I think I should write here. Operating system. Okay, so today is a little bit of concept oriented, assuming that a lot of people are new today. People might have not attended the orientation session, so I did not really go into the practicals aspect of it. But what we do in the next session is totally a practical approach. In fact, the second topic that we are going to do is also writing the test scenarios and test cases. Definitely, I'll cover it, Mainal. So tomorrow's topic will be majorly on how do we write test cases and etc. It's a completely a practical approach. We'll take a project, we'll take an application, and then we'll go about writing the test cases. Minal, anyway, this is just a very high level touch of SDLC. I have not discussed in detail. I'll be discussing it in detail. As you can see, somewhere we have kept it here, right? Fifth topic, software development lifecycle. But again, since you asked, let me cover that. So what I was saying is SDLC stands for Software Development Lifecycle. Typically, any software company will try to follow some life cycle through which they can deliver the projects to the customer. There are different SDLC life cycles like waterfall, V model, fish model, spiral model. The latest trend in the organizations is agile models. Okay, so that's what is SDLC talks about. And whatever I kind of explained it here is something is pretty much is a waterfall. And how it will be different when we go to agile, none of these terminologies will be here. So here we are calling it as requirements, there it is called user stories or epics. Okay, epics and then user stories, and so there are different terminologies. So when we talk about agile, we'll talk about totally in agile terminology. But for now, but for any model, waterfall model is the base, which is introduced around in 30 40 years back, rather 1970s. So how it goes, typically what it says is any project that you wanted to develop, any application that you want to develop, first gather all your requirements from the customer, what exactly he's looking for. Suppose, let's say you are simply building an online, yes, waterfall is still in use. Waterfall is a major for any of the model that you talk. They are just all, customized versions of waterfall. Nothing, waterfall is still there for last 40 years and it will be there. Okay, so what happens in requirements is that you will go talk to your customers and understand what solution that he is looking for. I'll talk about what is prototype, what it includes and everything in detail once. Okay. Uh, there are entry-level jobs in QA. Definitely there are QA in the sense testing. Again, now after defining it, I should be able to clear. Yes, there are entry jobs right from 0 years of experience to people ask 1 years, 2 years, 3 years, and up to 12 years of 13 years of experience. There are jobs on QA. How many months it take time to learn manual automation? Manual, I can tell you this about. Sessions will be about 12 plus another 8. You have to go through videos, so 20 days of time that you have to allocate, plus preparation from your side you have to allocate. That's a manual part. Automation, depending on the tool that you pick up, Selenium or UFT, and the training time, practicing your time. So in a 2 to 3 months from now, you can be master in manual. Plus you should target yourself, like course, yes, can be done in 2 months, but again after that you need another 1 month to be master in both manual plus automation, and then you can start applying for the jobs. Harini, I have clearly defined. What do you mean by QC? You're talking about quality control testing. Is that what I have just explained? So I'm talking about QC only from here onwards. It's nothing but testing. But again, I told you people use this very interchangeably. QA also people will call it as anything that we say QA or QC from now. It's all about testing only. It's all about testing only. Yes, there will be a lot of jobs and testing. Okay. Uh, I'm sure if the question to ask here, I was watching Karthik's QA of air, can I consider that as one of the option for me? No, so for this particular training, what I have done, be clear, I will be sharing this Google Drive document. I have created one Q&A document. You can put your question. So actually in IT-elearn website also we have a forum. My suggestion is either you put it there or put it here. I have created one exclusive document for this session Q&A. You can put it there, or if you go to IT-elearn website. Okay, so if you go to the website, there is a forum. Okay, technical forum. You put your questions there. Here under the forum, you can put your questions. I will be coming and answering it there, so that the broader people can also get it. Okay, so I will be covering up this SDLC in detail. Nothing to worry about it. Due to short of time, I'm not able to explain it in detail. But I told you fifth topic we will be covering that in detail there. So there is a next session lined up from Karthik on the Selenium. I need to hand over. We need to wrap it up. So with this, I would say what I wanted to cover in day one is pretty much covered. The fundamental definitions of QA, testing, blah blah blah, and then followed by QA/QC difference. So tomorrow onwards, it's all practical approach. We'll take an application, we'll start writing the test scenarios. In fact, you will also be think through and giving me some scenarios and test cases. It's like a more of um, towards direction approach. It's not just a single way that I will be explaining and you will be listening. We'll do that kind of a brainstorming for writing the test scenarios and test cases. Okay. So with that, let's park it here, and we'll continue tomorrow on the second topic, that is writing the test cases. So keep discussing it in forum. Keep putting the questions on the chart as well as the QA document that I've shared. We'll sync up tomorrow. Good evening, good morning, wherever you're from.